Welcome guys to today's class. In today's video, we want to discuss another important topic in physics, and that is equilibrium of forces. If this is the first time of coming across our video, please don't forget to click the plus sign, follow us on TikTok, follow us on YouTube. On YouTube, follow us with the handle Chidons Daniel, and also follow us on the Chidons Academic class on YouTube. So these two handles are our channels on YouTube. Please support our channel by following us on TikTok and on YouTube. We have a lot to learn in these two platforms. Okay, now when you hear equilibrium of forces, equilibrium, these two or more things are in equilibrium. Yes, when you hear equilibrium of forces, this equilibrium of forces, we have demonstrated them in many ways, both in practical physics and otherwise. Yes. What comes to your mind when you hear equilibrium of forces? Two or more forces are said to be in equilibrium if the total resultant force of it is equal to zero, or if the resultant torque of it, that is what we call torque. Torque means force times distance. So if the total torque of it is equal to zero, and if the total or resultant force of it is equal to zero, so three or more forces are said to be in equilibrium if the resultant torque is equal to zero, or if the resultant force acting on it is equal to zero. Yes. Now this topic, equilibrium of forces, you will see it in moment of forces. You also see it in couple of forces, couple. You see it in couple, you see it in moment, so to speak. Okay, and so we just want to see how to solve these questions we have, so to speak. Yes, as we want to solve these questions, question number one says a body of mass 20 kg is suspended in air by means of an inextensible string attached by the ceiling. What do they mean by that? Look at a ceiling. We'll use it to represent our ceiling, and the body is what? Attached to this ceiling, so to speak. And look at the body now. We say it's 20 kilogram. So to Newton, 20 times acceleration due to gravity, which is constant to be 10. 20 times 10 is what? 200 Newton. That is the weight of the body. This is the mass of the body, and 200 Newton becomes the weight because we use acceleration due to gravity as 10. Then they said another cord B is attached to the body and pulled horizontally. Remember, they said that this is inextensible string. That means you can't stretch it again. It is a type of string that you cannot stretch again. That's what we mean by inextensible. It cannot be stretched again. So when a force here is what? Dragging it this side. Another B is attached to the body and pulled horizontally on the cord A, makes an angle of 30 degrees with the vertical. So when a force F is dragging it horizontally, what it means is that when you have this vertical string you are seeing here will no longer be vertical, because when it's dragged, it will now move to something like this. So it will no longer be vertical again. It will now be what? Bent, because something is dragging it. And this is the body. Then look at the force, so to speak. Now they said until the cord A makes an angle of 30 degrees with the vertical. So it's making an angle of 30. Look at the cord making an angle of what? 30 degrees with the vertical. Okay. Remember that every weight of a body acts towards the ground, or is directed towards, or is acting downwards. And so weight of this body is going to be acting what? Downward. So it should be directed to down. So that means here is 200 Newton, and this is the force. Direction of the force moves this way, and this is where the tension comes. because the tension is on that string or on that cord, so to speak. Now, we now say that calculate the tension T. To find this tension T, this T, another question can say find the tension, find the force F. To find this tension T, let's see how to get it. To find it, you use a theorem called Lami's theorem. Lami's theorem, if you want to get it as fast as possible. How do you use Lami's theorem? Here is 30 degrees. You carve out what? The 30 degrees here. We said that here is also 30, and the totality of here is 90. This vertical and horizontally, so 90. 30 plus 90 will give a totality of here to be 120 degrees. Then here is 30. If here is 30 and this is alternate to this 30, giving you 32, the implication is that what? Here should be what? 60 what? Degrees. So 30 plus 60 gives you 90. Here is already 90, horizontal and vertical 90. 90 plus 60 will give you total of this to be what? 150. So 90 plus 60 is 150. And here is what? 90. Now watch this diagram well. Watch it well as I put it here. This is your tension. Then this is your horizontal. This is your 120. And this is your what? Vertical. Acting downward. So we have here to be 90 and we have here to be 150 and we have here to be force. We have here to be 200 Newton. Lami's theorem says that if you want to use it, this tension you are seeing here, look at it. This tension you are seeing here should be all over what? The angle, sine of the angle opposite it, all over sine 90 is equals to this force you are seeing here should be all over what? Sine of what? 150. Then you also say again that it is equal to this weight you are seeing this all over this one. Weight is 200 all over what? Sine 120. So with this is what we call Lami's what? Theorem. With this, you can get your tension and you can get your force. Let's get our tension. I'll compare this tension and this one. Therefore, when you have T over sine 90 equals to 200 over this, the implication that T will be equals to sine 90 times 200 all over sine 120. T equals to sine 90 times 200 all over sine 120. You use your calculator to sort it out. Sine 90 times 200 divided by sine 120. That is 230.94. 230.94. This becomes the answer. That is about your T. If you want to get the F, the force F, this F, you say F will be equal to sine 50 times 200 all over sine 120. Sine 150 times 200 divided by what? Sine 120. That means 115.47. So F will be equal to 115.47 Newton. And T will be equal to what? T will be equal to 230.94 Newton. So T is equal to 230.94, whereas your F is 115.47 Newton. But you see, they gave you all those options here, but they are looking for tension. You say your tension is 230.95, so to speak. Okay? You go to question number 2. Let's solve question number 2. Find the center of mass of 3 particles M1 2 kg, M2 4 kg, M3 6 kg located at 3, 4, minus 2, minus 1 and 4, minus 3, where the coordinates are in meters and options are given. Please, before I forget, note that this equilibrium of forces we are discussing, the equilibrium is divided into two. We have stable equilibrium, unstable equilibrium and neutral equilibrium. For stable equilibrium, we say that the center of gravity of it is located within the base. Yes, but for unstable equilibrium, we say that the center of gravity of it is located outside the base. And also for neutral equilibrium, we say that the center of gravity of it is always located within the base. Watch what we mean by a body being in stable equilibrium. You have a funnel like this. Let's say your funnel, and look at it, and it's kept this way. When you face your funnel this way, it is called stable equilibrium. That means when you tilt it small, it will return to its original what? Base. That means the center of gravity of it will be located what? Within the what? Base. But when we have something like this, as a funnel, you are standing your funnel this way. Instead of this round base to be down, it is now up. We call this to be unstable equilibrium. Yes, and that is why we said the center of gravity of it is always located outside the base. Then when you have it this way, you say it is for neutral what? Equilibrium. That you just drop it by the side, using the side part of it to drop it. Now, we now notice that the center of gravity of this will be located always within the base. If you tilt it, it will return back to this original base. It will just move and return back. I get it. So it is always within the base. But this one, if you tilt it small, it will fall. It will not return back. This one, when you tilt it, it will still return to its original base. Please have it in your mind. This is for stable, this is for unstable, and this is for what? The neutral equilibrium. Now, going to this question is simple to solve. You tell them that x coordinate is equals to, how do we get it? You say m1 x1 plus m2 x2 plus m3 x3 all over m1 plus m2 plus m3. Then y coordinate is equals to m1 x1 m1 y1 place plus m2 y2 plus m3 y3 all over m1 plus m2 plus m3. And it continues. If you are giving m4, you continue like that. m4 s4, m4 y4. So we are putting a continuous. So how do we do it now? Please label appropriately and take note of what. So this is your S1 and this is your Y1, S2, Y2, S3, Y3. Label them appropriately. So we now have that our S will be equals to, what is your M1 is 2 times what is your S1 is 3 plus what is your M2 4 times what is your S2 minus 2 plus what is your M3 6 times what is your X3 4 all over what is your M1 2 plus 4 plus what 6. You add them up. You use your calculator to compute them accordingly. Bracket 2 times 3 plus bracket 4 times minus 2 plus bracket 6 times minus 4 divided by bracket 2 plus 4 plus 6. That will be giving you minus 2.16. Let's check it again. We say 2 is the first one times S1 3 plus 4 times what? x2 minus 2 plus 6 times what? x3 is 4. And so when you finish it, you now say 6 minus 8 plus 24 divided by 10 divided by, this is 12, divided by 12. That is 1.8. So this gives you 1.8 meter. You check the one of y. Please, when you do it, you check it again to know whether you are correct. Because while I was pressing this, I omitted something and I was getting a different answer. That is why I have to look at it, because I didn't get any option, any value that is in the option. So that is how I have to check it again. So you do likewise, cross check what you are solving. Then for y, you follow this. 2 times your y1, 4, plus 4 times what? Minus 1. 4 times minus 1 plus 6 times what? 6 times what? Minus 3. All over 2 plus 4 plus 6. Okay. You now do 2 times 4 is 8. Then minus 18 divided by 12. That minus 1.2. This gave you minus 1.2 meter. And so, how do you package it? Coordinates goes as x, y. So what is the value of x? 1.8. What is the value of y? Minus 1.2. Please don't interchange. If you write it as minus 1.2, 1.8, which option will you take? You take this, and that is wrong. Please, this is wrong. It goes with x first before y, and this is correct. So we go to question number 3. This question is question on moment. And they say a uniform being HK of length 10 meter and weighing 200 Newton is supported at both ends as seen in fig 7, this fig. A man weighing 100 Newton stands at a point P. Okay, you sketch it. They said that here is a point P and a man weighing 100 Newton. That means the man will be moving down. It will be pushing this down. So this is 1,000 Newton. That is for the man. And they said a uniform beam HK of length 10 meter. It means that total length here is 10 meter. That is the total length. And weighing 200 Newton. Now, you need to know that there's what we call center of gravity. The center of gravity is the point at which the weight of a body acts. For a uniform meter rule, the center of gravity acts at the midpoint of it. Yes, that means midpoint of this is at 5. It means that this weighing 200 Newton means that the weight of this roller will be acting at the midpoint, which is what? 200 what? Newton. And so they said here is pivot or support. Then they say a man weighing 100 stand at a point P on the beam. We have sorted that one out. If the reactions at H and K are 800, if the reaction at H and K are respectively 800 Newton and 400 Newton, that means this one is H bar. The reaction means force that will be acting upward, and this is what? 800. Then this one, the force acting upward is 400 Newton. Then the distance HP is what? Here is your P. Here is your P. Remember the total distance is what? 10 meter. Now, they say get the distance HP. That is this distance X. Now, you know that since this is the center of gravity, distance from here to here will be what? 5. Distance from here to this point will be 5 meter. Whereas from here to here will be 5 meter. Making a total of 10 meters. Now, how do we solve this? Knowing that it has two upward forces known as the reaction force. It has two upward forces. We will say that to get the value of this x, I will say take the reaction, find the reaction on what? Find the reaction at what? At point K. Find the reaction at point what? K. And what do they mean? Finding the reaction at point K means reactions. Take the reaction at point what? Reaction on point K. On point K means take moment about what? Take moment about what? Point H. About point H. That is what it means. So if I'm saying find the reactions on point K, it means take moment at what? On what? About what? Point H. What it means that this is the point H and this point K. So finding the reaction at point this K simply means take moment about point H. How do we take the moment? You said that taking the moment towards the point H means 1000. This will be moving like this clockwise. This will be moving like this clockwise, and this will be moving like this anti-clockwise, trying to what? Meet this point H. Now you remember that there are two rules or conditions that are to be met when solving question of moment. Upward force, total upward force must be equal to downward force. That is one. Two is that moment, total moment about the what? Sum of moment about sum of clockwise moment must be equal to what? Sum of anti-clockwise what? Moment. The total moment about the clockwise direction must be equal to the what? Total moment about the what? Anti-clockwise direction. And moment simply means force times perpendicular distance. Do you remember that 400 was moving up, 800 was moving up. 800 plus 400 is 12. Downward 200 and 1000, that is what? Divided by 12. That is 1.8. So this gives you 1.8 meter. You check the one of y. Please, when you do it, you check it again to know whether you are correct. Because while I was pressing this, I omitted something and I was getting a different answer. That is why I have to look at it, because I didn't get any option, any value that is in the option. So that is how I have to check it again. So you do likewise, cross check what you are solving. Then for y, you follow this. 2 times your y1, 4, plus 4 times what? Minus 1. 4 times minus 1 plus 6 times what? 6 times what? Minus 3. All over 2 plus 4 plus 6. Okay. You now do 2 times 4 is 8. Then minus 18 divided by 12. That minus 1.2. This gave you minus 1.2 meter. And so, how do you package it? Coordinates goes as s, y. So what is the value of x? 1.8. What is the value of y? Minus 1.2. Please don't interchange. If you write it as minus 1.2, 1.8, which option will you take? You will take this, and that is wrong. Please, this is wrong. It goes with x first before y, and this is correct. So we go to question number 3. 1, 2. That means upward and downward are equal, so they are balanced, so to speak. So we need to get the value of x here. To get the value of x, I will say these two are what? And clockwise, and this one is anti-clockwise. This times x, we have it to be 1000 times x plus 200 times what? From here to here is 5. 200 times 5. 200 times 5 equals to Then this one that is anti-clockwise, 400 times 10. 400 times 10. So this is 1000x plus 1000 equals to 4000. Okay, this go here. We have 1000x equals to 4000 minus 1000. X will be equals, this will be giving me 3000 all over 1000 equals to 3 meter. So that means the distance from here to here is 3 meter. The distance from here to here will now be 2 meter. So here x is equal to 3 meter. Then from here to here will be equals to what? 2 meter. And from here to here will be equals to 5 meter, so to speak, giving you a total of 10. So that is how to solve this problem on what? Equilibrium of forces.